All right. I'm a little late. I accidentally hit a button and Visual Studio updated. Came up with like, oh, Visual Studio needs an update. And I just wasn't thinking, and I clicked on the update now button, and over 1,000 little packages had to install. It was like 3.5 gigs. It was so. Anyway, excuse me. Lap Goblin tried to nip at me. Okay, so now that we've been updated, and yeah, it literally uninstalled a bunch of packages and then installed them again. It's just so stupid. Okay, so I have gone through all of the fluids, all of the fuel-based crude oil products. Did I really close the Explorer? I think I did. Programming, vintage engineering, mod, assets, vintage, the items, liquids. There they are. So I went through all of these. I've rebalanced everything. Rebalanced them. I've even redone the tag here, right? Instead of like energy kilojoules per second, like that doesn't. The kilojoules per second stuff doesn't really blend to my power system. The power system for the mod is more generic than that, and it's kind of gamified to not be confusing to people who aren't electrical engineers or electricians. So it's just power per second is the rating, and then the networks, the LVMB, HV networks. The only caveat to those is how much power are they able to move per tick, right? There's a ceiling of the power. So like LV networks are 500 power per second is all that's moved on in any given tick on an LV network, and then MB is going to be higher than that. I don't know what a good number is for MB. It's going to be high. It's going to be like 15,000. I mean, it's going to be way up there. And then HV will be like not unlimited, but very, very high. Very, very high. Probably, millions of power per second, like way up there. So I wanted to reduce the fuels down to a power per second rating, and then balance the amount of power that we get via the recipe for creating them, right? The distillation tower recipe creates all these fluids, and I wanted to balance and make sure that it was basically top heavy in terms of how much energy we get it. So just doing just burning crude oil is really nasty and really bad, and is going to give you some power, but it's always better to process. The highest level process you can get, the better, right? The most you can afford, the better. So crude oil, I think, is 700 power per second. But all the durations were all standardized to 5 seconds. Having too many knobs on the dial to try to tune, like if you're dialing power per second and duration, you're going to come up with like really bizarre things. And it makes sense to me that the duration would be the same because it's fuel. You have the same number of cylinders. You have the same number of, the volume of a cylinder, whatever that, whatever you want to calculate that to be. But the volume of fuel that you're using is the same regardless. It's just what amount of power. Basically, simulating the power per second rating changing kind of simulates very abstractly the what do you call it in actual fuel? Like when you like the difference between like 87 octane and 91 octane, right? The difference is how much pressure. I think it's how much pressure the fuel actually gives you, right? So really high performance engines needs that high octane for the higher pressure because there's, you can extract more horsepower out of it. I think. Correct me if I'm wrong. But I think that, and that's why, like, if you put like nitrous oxide, like the Fast and the Furious movies, when they boost their cars with nitrous oxide, if you don't have an engine that's capable of sustaining or withstanding the pressure, right, the cylinder pressure of something like that, your engine will explode. So that's kind of what I'm simulating with the different power per second rating of the different fuels. The higher grade the fuel, so like heavy oil is going to be a horrible fuel. It's like 800 power per second. But again, all the durations are 5 seconds, right? These are per portion, which is 10 milliliters. It's a tiny amount of fluid, but the difference is, like, if you're burning heavy oil, it's a sludgy, cruddy, polluting thing. So the soot is really high, which isn't used, but it still is a thing. Versus like LPG, which is very, very clean burning. It's used, this is where you get, your cooking fuels and stuff, like your backyard barbecues and stuff, come from the upper echelon of the distillates. So you have the naphtha and you have LPG, which naphtha is a lot of those, propane, butane, acetylene, a lot of that stuff comes from naphtha. And then LPG is liquid petroleum gas. It's just like, that's like the top tier. Those are going to be more energetic. I think LPG is 1,300 power per second. But it has almost no soot. So, but it's still, you're getting more energy. The more stacked your distillation tower, the more products you're getting out of it, the more energy you're getting, with one exception, and that is lubricant. Lubricant is not a good fuel. I did add a liquid fuel section to lubricant, but yeah. Anyway, lubricant is not a good fuel. It's the only tier of distillation tower that isn't a net gain of power, right? You actually go backwards a little bit because lubricant is just not a good power. But my plan is that lubricant, we're got to figure out a way to apply lubricant to the generator with some sort of behavior, something. We want to do something with an interface that's like iLubricatable or something like that. I need some ideas on how to name that. iLubable. Because lubricant, then we will be able to enhance machines, especially like the generators and some of the other machines. Maybe, the big ones are a little less so. Pump jack is definitely, I want to include it in the pump jack. I want to include it in the generator. The drill derrick, not so much, because that's the only moving part of the drill derrick is the spinny bit way up at the top, the motor way at the top. That's the only thing there that technically would move, or that would need lubricant. I don't want to deal with that. And then the distillation tower doesn't really have any moving parts itself, so that's not really a thing. But the generator is definitely one that we were going to want to enhance, and that is just going to be a flat if it's lubed, it's going to have a bump in output. Basically, it's going to have a modifier of the output. So the burn time will be the same, but because it's lubed, you'll be able to essentially like get eke a little bit more, and that's when the lube comes from the distillation tower. Instead of burning it, you're gonna want to like use it in your machine, and there'll be plenty of other MB based machines that would want it or use it. So I'm hearing noises. That cat is a terror when I stream. I swear to God. She's the kindliest, cuddliest cat during the day, any other day. And then when I stream, it's like, I'm going to be a terror. Okay, so what we're doing today, because I've rebalanced all the fuels, what we're doing today is we are going to try to plug in try to plug in the generator to actually do some things. Okay, we want to be able to generate power and be able to extract that power from the generator and make sure that is all working, because this is the first actual power producer that we have in this tier. Let me know if you guys need to see the text a little bit better. I can make it bigger, but it's just it limits how much I can actually see. So the liquid fuel properties, I've already updated this with the power per second tag. So I've changed the tag here, and I've changed the actual variable that tracks it. So we have this one reference. Yeah, item liquid fuel. This I had to create a custom version of this because for some reason item liquid portion is an internal class and I can't I couldn't derive from it. I don't know why it's an internal class. It's an item liquid portion. I don't know why it's internal, but I couldn't I couldn't use it. It's one of those either an oversight or somebody had, I don't know. Honest to God, I don't know. I don't know why it's an internal class. But basically I just replicated the code that it had. But I got it is what it is. This is the thing that looks at the tag, the custom tag, liquid fuel, and this is where it pulls all of the values, right? And then shows you when you're holding it. But we will be able to identify what that is. Okay. Now, the generator. This all is in. I can build it in the world and place it and everything. It just doesn't do anything right now. As you would expect, it doesn't do anything. So, I want to change capacity leaders. So the problem right now, I don't know how this is going to react, because I might need to set this to a different value, because the item slot liquid only Pat, you were just in my lap, for Christ's sakes. You want to come back to the lap? I put the air conditioners in the window a couple days ago. She's still adjusting. Yeah. Lap Goblin is back. So the item slot so this doesn't edit at all the max size. So if we look at actual item slot, the base of all the slots, the max slot stack size get so something in here gasifier. Okay. Because I remember I remember debugging this and looking at max slot snack size and having it's like inherently set to like 100,000 or something like that. No, here it is. Yeah, 999,000. Okay, so you might look at this and go, "Wow, that's a high stack size. That's a lot." Well, here's the problem. The stack size is different from capacity liters. Okay, so capacity liters, if you have a thing that holds 50 liters, okay, 50 liters, if you actually look at the number of portions, right? So capacity liters is 50 is fine, right? That's not going to change. It's the stack size of the slot that's actually important, okay? So the problem arises when you have slots that hold a lot of items, right? A lot of liters. This is why I had to roll my own slot for the tanks, because the tank needed a lot more space for the big amounts of fluid, because it was literally in the thousands of liters. I think the steel tank is like 256,000 liters, right? It's 256 blocks, essentially blocks of fluid, right? But that's 256,000 liters. Well, you multiply that by 100, and that's how many portions you get. So the actual slot stack size is 100 times the liters. So with this at 800, right? 800 liters is less than a block. I think we're going to be good with this. because this would be 80,000. This you times this by 100, right? So it'd be 80,000 portions. I'm pretty sure. Yeah. 80,000 portions. Which is it's plenty. Like it's way under the 999,000. So I think we're okay with the capacity being 800. And again, this 800 liters comes from sort of industrial generators. I kind of just split the difference with the range of sizes and capacities and stuff. But again, it's going to use a portion every 5 seconds. Okay, so we could easily, roughly calculate a portion every 5 seconds, and this thing will hold 80,000 portions. So we go 80,000, right, portions times 5 seconds per portion. That's 400,000 seconds. This is real life, this real-time hours, or a real-time minute, or seconds, by the way. 400,000 seconds. Divide that by 60. That is 6,600 minutes. Wow, that is going to be... Okay, that's 111 hours. We might need to dial our durations down a bit. We might need to dial them down. 111 hours? That's 4.5 days. That generator will run. That's real life days. That generator will run on a full tank. I don't know. Is that on, like, I would imagine on servers? I would imagine on servers that would be good. But you're going to need more than, you're going to need at least, if you're burning diesel, you're going to need a minimum of 2 of these to run the distillation tower. Distillation tower base is going to be 2,000 power per second. So you're going to need 2 of these running in order to run at full blast. You're still going to get power out. You're still going to get enough power out to do that, but it's a pretty decent amount, because that's just one example of one singular full tank, right, running. So how much does 800 liters, how long does it take? Well, 800 liters, the problem with this is now Hey, Hoss. How's it going? So the conundrum right now is I've balanced all the fuel around a 5-second burn time. But that means a full tank of this will last 4.5 days. Like real life days. 800 liters in the generator. 800 liters would last in the real life days 4.5 days, which is, I mean, at 40-minute days in the game, because a portion burning for 5 seconds, a portion is 10 milliliters. The problem is the scale from real life time to game time. That's the biggest problem. Because A, that can be variable. I've known people who play where an in-game day takes real life days too. Real life days per in-game day. So people play with that scale a lot. Of how fast time passes in the game. Which scales everything, by the way. Like everything scales by that. Craft times, smelt times, all of that. You can put a crucible if you're actually doing real life days to one in-game day, you can put a crucible in the fireplace, and then the next afternoon you get home from work and it might be smelted. Like we're talking hours and hours and hours. Like hours of time to get that actually heated up and smelted. Because everything in the game is scaled by that value. So
yeah, I don't see how that's fun.
I don't understand that at all. Even on a 24/7 server, that would be crazy.
I'd run out of things to do.
Everybody would. There's not enough to do in the game. Like you plant all your crops, and you're just like, well, those crops are going to be ready in August.
Yeah,
because it's literally August, right? In real time, it's going to be like, well, those are going to be ready in about 2 months to harvest. So, God, I gotta forge ahead here. So we could adjust how much fuel is in the machine, because remember, a single craft. Let's just do baseline distillation tower, no extensions. Right? It's 500,000 power to finish one craft. The tower itself is 2,000 power per second. No extensions. So 500,000 power to craft, it's roughly about 3 hours in game. That's what I balance it off of. So you're consuming 500,000 power, and then in diesel, what you get out is roughly 850,000 power worth of diesel. Right? So 500,000 power in, 850,000 power out, essentially. So you get a net gain. It's a net gain of power, no matter how you look at it. That's how it's balanced. But you get from the 10 liters of crude, right? You put 10 liters of crude in per craft, you get out 1.7 liters of diesel. Okay, so it would take a whole lot of those cycles, right, to get 800 liters, especially because you need 2 generators to run the thing. So I'm on the fence about maybe the generators have a small internal tank, and you can change the size of the tank you have connected to it, right? You have tanks that are attached to it, so you'd need a small internal tank, but that doesn't match with how generators work. Industrial generators have enormous tanks because you want to fill it up, start it, and forget about it for a whole day. So a lot of the industrial generators will run for 12 hours on a single tank. Now 12 hours in real time, 12 hours is 40, 80, 120. That would be like at least 16 to 20 hours in game. No, 16 to 20 days in the game is 12 hours. So that the math for scaling, I don't know how to do it. Like, if the portions are burning too fast, like if it's like crazy fast, 1.7 liters. Let's calculate here. 1.7 liters is 170 portions. Okay, so we times that by 5 seconds. That's 850 seconds of burn time. Right? That's 14 minutes. That's 14 minutes. 14 point blah minutes of burn time, which would be, because we would need 2 of these, so that would be 7 minutes apiece, right? If you're splitting the fuel out, right, half goes here, half goes here. You can't see my fingers. Half goes here, half goes here. That's 7 minutes. Well, the craft takes 5. Right? It takes 5 minutes. So you're going to get a net gain barely. So the incentive there is you want to build more extensions to get out more product, right? You're getting out more of the fuel, and then the top tier, it's a massive gain, right? Rather than a net gain with no extensions, the net gain is like 350,000 power. That's your net gain. With full maxed extensions, right? Super expensive because you got to go build 6 of those things. So, iron sheet metal and blah, 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 blah. Like, very expensive. The max size distillation tower is a net gain of like 3.4 million power. Right? It's a net gain. So that's pure profit. It costs 1.5 million power to do that, and 5,000 power per second. So it needs 5 generators minimum, roughly, to do that. I don't know. I'm gonna keep the balance the way that it is with the burn time and stuff. And if again, putting this in the hands of people, putting this in the hands of players and y'all, if something doesn't feel right, if something doesn't play right, if it doesn't feel like it works, or it's too good, or it's not good enough, like, I try to balance it around, real world, sort of very generic real world, but I still try to balance it. But I'm open to ideas on how to rebalance it. I just don't know kind of what to trigger. So we want to do the thing here. So, where's my inventory region? There it is. Region inventory stuff. Okay, so we have input tank, blah, blah, blah. We want, why did you put that there? That was weird. So inputs left.empty, return false. If input slot, God, stop doing that. Dot item stack. Stop. Dot collectible. Dot class. Why did that happen? Dot class. It's a string. Dot class equals type. Item liquid fuel. Registry object. Collectible object dot type. Get type equals it does not equal type of item liquid fuel. Return false. And I'm comparing. I'm saying, hey, if if it's empty, return. Obviously, return. If it's not empty, check the item stack. If the type is not an item liquid fuel, right? This, which if we look at this, you can see item liquid fuel. So very specifically, item liquid fuel, because it's going to be looking for this tag, and I need it to have that tag, right? So, I also want get auto push into slot. From slot. Oh, no. If from slot.empty or from slot.item stack collectible is liquid. So that's looking at what's coming from. If I input slot dot item stack dot empty. Oh no, input slot dot empty. If not input slot dot empty and input slot dot item stack dot equals dot collectible equals from slot dot item stack dot collectible. If input slot dot if not input slot dot and input slot dot item stack dot collectible does not equal return null. So that's checking the from slot and the input slot. That's saying, hey, if what I have, right, maybe I have gas, but the from slot is kerosene, those are not equivalent fluids, then we don't have a slot for you. Okay. Then we want to check if input slot that item stack collectible, let's see. If from slot dot item stack dot collectible that I get type does not equal type, return null. Okay, so only only allow fluids, item liquid fuels. Only allow item liquid fuels in. So it kind of makes this check superfluous, right? Because this is not going to allow anything that's not a fuel in there, but just on the off chance something does happen, I want to make sure that we do a check there, because if I try to grab those attributes and they don't exist, right? What do you do with that? Like, how do you handle that? All right, this will be the end of my coffee. Okay, so now if input slot dot item stack dot attributes of liquid fuel dot exists. What? Attributes dot has attributes liquid fuel. I thought for sure there was a dot exists, but maybe not. So liquid fuel. Okay. So we want liquid fuel properties. Should I I'm going to think about this for a second. So there's a few moving parts to this. The find matching recipe is like what recipe, and it's not really a recipe. I just, all of my other machines use this nomenclature, so I'm just going to use it. My internet just hiccuped, or something happened. I went down to 0 bits.
Okay, I see the stream started back up.
Yeah, like
You were down to nothing.
I've been really worried. They're doing a unholy amount of construction on the avenue right down from my place, which is the main drag for the internet. Like the ISP came out and you know those little flags they put in the ground with the spray paint where they're marking. It's just the whole avenue is marked with, you know, all of the gas lines and all of the things, and my ISP has buried cables up and down that avenue, which is where all these internet connections go. And so I'm like, this whole summer is going to be up in the air. In any moment, they could accidentally sever one of those lines and knock the internet out for hundreds of people. So I'm just like, at any moment that could happen. So when that dropped just now, I was like, oh shit, did I just lose internet completely? Because it's all fiber, right? The ISP ran fiber through the whole city. This whole city is now wired with fiber. And when you break fiber, it's a bitch to put back together again. It's a nightmare. So it's like, yeah, that would be bad. That would be very, very bad if they knock that out. But it could have, like, at any time this summer, it could happen. Hell, my power could go out. Although that's That's not buried in the ground. Okay, so that just made me panic a little bit. Either that or YouTube's going back to the dropping the frame things. But I have 0 drop frames, so that was definitely a internet hiccup. I would love to know what caused the drop frame issue that I had for about 6 to 8 months, maybe even a year. That's when I started streaming to Rumble, because it was like YouTube kept dropping my frames, and like 40 to 60% of my frames would drop when I was streaming to YouTube. They did something in their internal servers that just hosed streamers.
Yeah,
Small
that's
streamers,
crazy.
for sure. But that's not been a problem for quite some time now, so I'm very happy with that. Okay, so the moving parts is: are we currently burning something? What is our current burn time? So the shorter the shorter the duration. Here's the problem, right? The shorter the duration, the more we're gonna run into rounding errors. Okay. So rounding errors are going to sort of throw a little bit of randomness into this process, because we're not guaranteed to get 10 ticks per second really evenly spaced, 0.1, 100 milliseconds exactly per tick. That's never going to happen, right? So you're going to get a little variation, a very small amount of variation in these calculations, because delta time is not going to be exactly 0.1. And so the power per second multiplied by that is, it's going to alter these numbers a little bit. So we could be at 4.99 burn time, right? And the next tick that runs is going to put us way over that, but it's still going to burn that last bit and then call it again. So you're going to get a little bit extra and a little bit less, a little bit more, a little bit less, and you're going to bounce back and forth. But over an extended amount of time, you should be able to hit really close to that, like 5-second duration. And this is the issue when I have people commenting about the LV generator, right, that burns firewood and stuff like that. People are like, well, we clocked it, and it's producing either a little bit more or a little bit less than what we expected it to. It's like, well, yes, that's because it's based on a burn time, and the duration is a little bit different. So it's kind of like there's a little bit of randomness, just like there would be normally. Like, you're not going to get really precise burn times. On the atomic scale, there's going to be variation. So, but as long as it's close, I'm not going to worry too much about it. Okay, so we have this has attributes. All right, so now we want the. I'm pondering whether to have the properties item. The liquid fuel properties have an object of this, or just set the variables. So if we go up to the variables here and we say, all right, we need private liquid fuel properties. Come on. It flashes up there. There. Oh, nope. Liquid fuel props. And then we can do a public liquid fuel properties, liquid fuel props. Okay. And then we want to float. Let's do a private float burn time. Current burn time. The burn power per second will be in this. The max burn time will be also in this. So we don't need one of those. We just need a variable for current burn time, which we also want to set this yeah. So this we want tree of current burn time equals current burn time. Oh, tree dot set float current burn time. Current burn time. And then down here, we come in and we say current burn time equals it just happened again. It just blanked again. Yep, it's going to be one of those summers, people. It's going to be one of those summers. Okay. Current burn time. And then this. So, so we grab the inventory, right? Inventory.fromTree attributes. We're reinitializing inventory if input slot dot empty. If not, I could stop fat fingering keys, find matching recipe. This is why, like, if you look at a lot of the code from a lot of my machines, this is the thing, right? Because we need to initialize the variables here, right? Especially like the liquid props. But this is not only initializing it when you like load the save or load a chunk, this is initializing it, but also for the client. So this same call is run on the client. So this thing, what we don't want to do with find matching recipe, we don't want to reset the burn time. All we're doing with this is saying what recipe what recipe is valid. And by recipe in this particular case, the recipe is what fuel are we burning? Right? That's all this needs to do is what are we burning? And then the current burn time is actually setting, okay, how far into it are we? Which, you know, if I needed to display something on the client, right? If you look at the machine and you get that data at the top of the screen, I need to be able to send this data to the client, which is, you know, why I want to sync this. But it's also, we also want to save it to disk, so it initializes properly. Okay, so we go back to wherever that was, somewhere in here. There it is. Okay, so we have has attribute liquid fuel. So we go liquid fuel properties. Well, we can do, yeah, well, yeah. Liquid fuel properties dot from JSON input slot dot item stack dot attribute. Item attributes? Attributes. Item attributes. I think it's item attributes. We'll see here in a second if this is good to go. Liquid fuel props. Okay. Remember, all we're doing is grabbing what we're, the properties of what we're burning. We're not grabbing how far into the burn we are, because that's not the scope of what this function is supposed to do. Okay, I think that is all we need here. I'm just on the fence about the item attributes versus item attributes. This is because it's item, right? I think the dot attributes is unique to the item stack that you have in your hand, or like the item stack. What attributes are unique to that? So that would be like temperature, like if you have an ingot and you're heating it up, like that would be temperature. That would be attributes. The item attributes are the underlying block and item, right? Because this is global. Well, this tag is global to the item, not specifically to the stack, just the item. So we have that is good to go. So in the initialize here, we also want to do this. If is built, then we want to do find matching recipe. Okay. And then else current burn time equals 0. Liquid fuel prompts equals null. Right? If it's built, but the input slot is empty, then we want to, basically zero out the variables. Now, here we go. We have this call here. This is where the rubber hits the road here. This is where we get electric max power per second. Rather than take that rated power, right? The rated power, instead of being the machine's power per second, which is what every other machine has, this is going to be pulling from if is built and machine state on and liquid fuel props is not equal null. Okay. Meaning we have fuel to burn. Rated power equals long. We want to do liquid fuel props dot energy power per second times delta time. Okay. But again, there's going to be rounding issues, just because I'm using long values instead of floats. I don't know if that's good or not, but this I want to be here. So we're taking the energy power per second of the fuel that we have, multiply it by the delta time, which is the number of, it's the fractional second from the previous tick, right? So delta time should always be less than 1. It'll be between 0 and 1. Now, if you have a delta time that's way higher than 1, that means your server's like that's like struggling. So this process is just scaled by the delta time. We can get rid of this. So this is how much rated power that we have. So this is the power rated by the fuel that we have and the delta time. So diesel will be 1,000 power per second, right? 1,000 times whatever delta time is. 0.1, 0.104, 0.98, point whatever. Right? And that'll get us how much rated power. And again, it's rounded because we're casting it from a float to a long. So there's a little bit of rounding error there. I don't know if it might be too late to change the power system. I don't know. Now we have current power. We don't need if current power equals electric dot max power return. Okay. If electric dot current power is greater than electric dot max or current power plus rated. Oh, I need to put this on this side. Rated power. If current power is greater than electric dot current power plus rated power, return. And this is Yulong Really? You can't add a long to a U-long, really? I need to use the bathroom. I'm going to be right back. All right. Okay, so if power is maxed, return and don't do anything. Or can I? I don't think I can break. Yeah, I can't break. But rather than, let's see, doing a return here, this is a problem. Doing a return here is probably not wise because doing a return here would never then call this function, right? This is the master key of what updates the client. Because I put in here a limiter on how often to update the client because there was way too much network spam when I was updating the client every tick. That was a problem. So I wanted a way to scale how fast to update a client. Doing a return here, it would never update the client, which would be that's a problem. So what I think I want to do instead, is if electric.currentPower does not equal electric.maxPower, and so we can get rid of that. Electric.currentPower is less than electric.currentPower plus rated power, and do that. That way we are able to still compare the things, but if any of these are false, right? If current power equals max power, this is false. And it won't even check this one because this one comes back as false. It won't even come in here. So then it'll hit this and actually be able to update the client. So yeah, I think that's right. Electric.current power is less than. So we want to go into this call, right? We want to go into this block if either of these are true, right? If current power does not equal max power and current power is less than current power plus rated power. We can even go less than equal to, because if current power is less than, well, no. Oh, Jesus. That scared me. Siege, welcome. Thanks for the sub. Okay, I think my math is off on this. If current power, this is always going to be true. So I want to, if electric.max power minus current power. If max power minus current power, which gives us how empty we are, right? This is how much power we have available internally. Max power minus current power is how much available power buffer we have is less than or equal to rated power. Okay. That's a little bit more in line with what I wanted. If max power minus current power is less than or equal to rated power, right? So rated power is how much power are we going to generate this tick, right? We need to, that information is like, how much are we generating this tick? And this gives us how much power we have available in our internal buffer, right? So if our available power buffer is less than or equal to how much we're generating, then that passes the test. Okay, so now we want to current burn time plus equals dt. Okay. So we add up current burn time, regardless of what that value is. If current burn time is greater than or equal to liquid fuel props dot duration. What? Right? So current burn time is greater than or equal to liquid fuel props dot duration. I need to change this. Okay. Okay. So we add our delta time to the current burn time. We check that current burn time to the duration, the total duration, right? Which is, it'll be 5 seconds. And then we do electric power plus equals rated power. Really? You can't add? I really should have used a different... If I were to redo the electric system, I would make it a double rather than a U-long. I think a double C# double dot max value. 64-bit double precision. It's an unbelievably big number, but it doesn't have a lot of precision on the top end. It's 1.797 times 10 to the 308, which is a very big number. I'm pretty sure represents a number that's bigger than the number of atoms in the universe. I'm pretty sure. Believe it or not. I think the number of atoms in the universe was roughly calculated to something like 1 times 10 to the 67th or something like that. So A number times 10 to the 308 is a big number, but we couldn't use all of that number because the precision only goes to 3, 6, 9, 12, 16 decimal places. So you can have 16 decimal places of precision. That's such a huge number. That's such a huge number. So yeah, I would change the power system to use doubles. Now I don't know what performance. Like, I know that modern CPUs are much, much faster at floating point numbers, and a double is just a giant ass floating point number. Yeah, adding a small number to double that max value, yeah. So the larger the number, the less precision that you get. But we're not dealing, I mean, we're talking the largest number that you could get with, why can't I, really? I can't, there it is. So this is the largest number. So if you do this, and you just remove this decimal place, right? This is the largest number that you could possibly get with without any floating point inaccuracy, right? If you took this number in a double and you added 0.1, it would return this number. There would be no change to the number, right? Which is where that precision comes in. So that is 100,000 million billion trillion 17 quadrillion. That's a lot of power. I would not foresee people. It's still less than a U-long, right? A U-long max value 100,000 million billion trillion quadrillion 18 quintillion. So it's bigger. It's more, right? This is the max value for how much power. And again, there is zero floating point with a U-long. There's zero floating point numbers. So this is the max value. If you added 0.1 to this, you would again get this value. You would not go up from this. But you know, that's so much power. It's almost 1,000 times more than the double. But would it really matter? Like 17 quadrillion, the amount of time it would take to generate that much power would be several lifetimes. I don't anticipate people generating that much. That was a little wishful thinking, but yeah, if I were to redo it, I would make it a double, and just be able to then, I would have to go through literally every function, every machine, and include the floating point calculation, because now we can have varying amounts of power. So, but I just thought of power as whole units, like a power is a singular unit. Okay, so burn time is liquid fuel props.duration. So burn time is now good to go. So input slot dot take out 1, right? We're going to take out one portion from the input slot. Okay. We are going to reset, right? And then find matching recipe. Because that one that we took out might be the very last portion, right? So we take that out, which zeroes out the input slot. I just realized when you take out the last one, We need to put that back here. Because if you take it out before you do this, it would set it to null, right? The liquid fuel props would be set to null. Then it would come in here, and it would never burn the last portion. It still wouldn't. No, it would. This would, because this... We reset this. I'm in a chicken and egg problem here. If we are the two scenarios, we're on the very last portion or not. Burn time is greater than, so we have burned the last portion. Or let's say we're on the second to last. So the input slot dot take out, we have one portion in there, and we're burning a portion, right? So we're actively burning a portion. Now the question is, yeah, we once the burn time hits the duration, then we take it out. But if there's one portion left, right, we set current burn time to 0. We're basically resetting that value. We're finding there's one in there. We're finding the recipe, and we're taking out that one, which essentially puts it it's actively burning it. But when we take out that input slot, that would likely trigger onslaught modified. If slot ID belong, if inventory of slot ID dot empty. God, stop doing that. If not, how did you get that wrong? Slot ID dot empty. Set state num state dot on. Now, I could do a find matching recipe in here, right? If I did, if find matching recipe, right, if it's true, set state to on. But what that find matching recipe does, if input that exists. So this, if it doesn't exist, liquid fuel prompts equals null. Kind of digging myself into the hole even deeper by doing this. But knowing exactly how this behaves is going to help me figure this out. Okay, so we know that I don't need to do this. Well, no, I do. This is the problem right here. What I might need is just a simple Boolean. Wow. Way to go. Is burning. Okay. So then we come down here. Tree.setBool is burning. Is burning. Is burning equals tree.getBool is burning. Okay, so we want to do if is burning equals true. Okay. Since I've changed a bunch of the logic here, we got to step through it. It's always the little edge cases that catch me, right? It's always little edge cases of like just the fringes of the feature is sometimes where it breaks. And then we'll load it up and see what we can see. Okay, so the find matching recipe here I might change this to actually control the is burning, because if we find a recipe, like if we find something to burn, I'm already calling this function in multiple places. I need a central place where this is burning variable is being tracked. So if we just set this, right, we would be able to come up here. Let's minimize this. Okay, find matching recipe. Then we can say liquid fuel prompts blah is burning equals true. Is burning equals false. But again, this is the chicken and egg problem. We get done burning the current one. Yeah, I think I want to take it out of here. Yeah. This is just setting the props. I want to set the is burning. So if we look at the slot modified, if find matching recipe right is burning equals true. We need a way where if it's empty, right, and then you put the first bit of fuel into it, there needs to be a way to set the is burning equals true, because there would be no way of getting past this otherwise. Right? We would set it on, but not as burning. So we need to have both of these turned on. Okay, so then we say current burn time equals 0, find matching recipe, which should grab that. We want to take out the one we just burned. We want to take that out. Wow, look at all that white space. I still have not found a way to clear white space in this new version. Like, there's still not a variable that allows me to trim trailing white space off of things. If not... Oh, God. Or I could even be even better with this. Is burning equals. Okay. So oh no, this still wouldn't. Damn it. Let's see. Let me just think this for a second. Let's take the scenario we have 2 portions left. This thing just ran with 3. Right? We had 3 portions and we were burning that third portion. Current burn time equals 0. Input slot.takeout 1 means we drop to 2. Is burning equals find matching recipe returns true. Because we find one. There's two portions in there. Okay. We run through. It's generating power. And I can short circuit, the current power. I can have it burn in the entire thing and then stop. I could have it stop in the middle. Doesn't really matter. But it's burning. Remember, there's 2 portions in there, but one of them is what is burning, right? I'm not removing a portion, burning that. 2 portions in there that are burning. It's running. That one triggers, right? Current burn time equals 0. Input slot.takeout 1, which means we drop down to 1 portion. Is burning equals find matching recipe, which is true. Because there's 1 portion in it. Process. Burn. Triggers again. Burn time equals 0. Input slot.takeout 1. Okay. The one that was in there now drops to 0. Is burning will be false. I think that's right. Because remember, the one that we were burning is not removed before it starts burning. It's removed after it's done burning. So that is, I think this is right. Because we take out the one, we take this out. Which will trigger this. So this is already going to be set. Set state. I got to be careful with the set state. If find matching recipe. So I have to set is burning equals true here, or I'd have to short circuit it here. I think I might do that. Instead of doing that, come down here and if electric.machine state equals enumbe state dot sleeping, if God, stop doing that. Input slot dot empty, find burn is burning equals find matching recipe. Okay. So if the machine's if we're sleeping, which I already do this up here, so I could just say do this here. Say it'll save me some if statements. So if it's sleeping, remember the sleeping thing is a way to not process the full tick every tick. It's a way to, if it's sleeping, it doesn't need to process everything all the time. So it's literally drops the full tick rate down from 10 times a second to once every 2 seconds. Right? It's a massive scale down of how much logic it does while it's sleeping, as a way to boost a little bit of performance, or as a way to just capture a little, to save some performance. So the update bouncer here, when it's less than 2 seconds, when it's less than 2, it'll return. So it'll come in here, bounce, come in here, bounce, come in here, bounce. And then once it's greater than 2, right, 2 seconds, then it'll finish processing and it'll check input slot.empty. And if input slot is not empty, meaning we got something in the last 2 seconds, we got something, right? We got some fuel. Boom, is burning equals find matching recipe. And then update bouncer equals 0 resets the bouncer, and then it checks this. But the find matching recipe here, I need to then possibly set the state. Do I want to set the state up here? I thought okay, if liquid fuel props equals null, set state to sleeping. But the problem is, no, I think that's, again, I need to test this. I'm pondering whether to do this up here or down here. I might do this. Yeah. I don't really like doing it in the recipe check. I like to keep this very tightly controlled, as like all this does is setting our props. If is burning set state enum.on. Because if we're sleeping, theoretically, if we're sleeping, we only need to turn on. Right? Because we're already sleeping. Then coming in here is burning. If we're taking this out, we can do if is burning, if not, God, stop with that. Not is burning, set state dot sleeping. Go away. The IntelliSense is just out of control. It's out of effing control. There's no intelligence behind it at all. It's just sense. If not is burning set state. Okay. So this, and no matter what this does, we burn. This is a burn tick. It's technically a burn tick, regardless of what the burn time is. It's still a burn tick. We still edit the power, right? We still increase the power. And then the next time it comes in, right? If we take out the last one, let's try to follow this. We take it out, that triggers slot modified. Inventory slot ID.empty. This is actually true. So it does not come into here at all. Right? So it skips both of these calls because it's empty. So the slot modified call doesn't really do anything except it increments the client update. All this does is say, hey, I want to update a little bit. I want to update the clients a little bit sooner. Right? That's all that does. So that call, that takeout one, doesn't really do much. It increases this, which might trigger it sooner, but this takeout doesn't really do anything on the grand scope of things. And then this one calls and says, oh, find matching recipe is false. There is no valid recipe. So is burning equals that. And then if not is burning, which means if we are true, don't do this, because we're already on. We know we're already on if we're in here. But if we're false, then we need to set to sleeping. And then increase the power, and then the very next time this comes in, right, is burning is false, and we're sleeping, it'll hit this, and it'll skip for 2 seconds. It'll come in here. Input slot.empty will still be true, so it won't check this. It'll come in here, is burning is false. It'll skip this, and then maybe it'll most definitely update the client. Although I need to make this happen up here. Otherwise, it's not going to update the client nearly as often. Yeah, client update delay needs to happen, or this needs to increment no matter what. Otherwise, the half second tick it would actually be every, because this would be every 2 seconds. So every 2 seconds it would increase, and then it would take, at best 5 of those. So you're looking at every 10 seconds the client would update. That would not be good. The client should update. If it's sleeping, the client should update every 2 seconds. It should be guaranteed. Okay. I think we have a thing here. Now, I don't think we have a custom block. Let's look. Block types, multi-block, fluid generator, class. Yeah, it's a core. Anytime we're dealing with fluids and blocks, it's just a pain in the ass. Multi-block. Activate. Unblock interact. Okay. We have a wrench. I'm trying to see where I could put in fluid. Like if you have a bucket of fluid in your hand. If we look at, say, the block for the tank, there's a bunch of code in here for interacting with fluids, and it's a pain in the ass with how the game handles it. So I would need to find a way. The multi-block core. Oh my. My voice cracked there. I love it. The multi-block core, while you're not directly interacting with it, any interaction with a dummy block is passed on to the core. Right? So VEMB core. I think it is. Let's look at the VEMB dummy. This is a block, multi-block offset. Yeah, this is get selection boxes, get collision boxes, blah, 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 get on getting broken, blah, 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 unpick block, interact start. So if you're not sneaking, so if you are sneaking, it's going to call the actual block. But if you're not, it's going to grab the offset and pass along MB, right, on block interact start. Interface or base or block. I mean, I know that my interface, well, it's an interface, multi-block interact interface. I know my behavior has it. Yeah, I multi-block interact. Okay. So it is calling the block interact start. Okay. Based up block. So round and round we go. I think this function is being called. It's like it's daisy chained from several things. Yeah, I think it is being called. So, how do we want to handle this? I'm gonna take this, I'm gonna float. Wait, can I? I can't float this? Oh, there we go. Just click and drag it. Okay, now I'm just going to have this on a different monitor so I can actually see what the hell I'm doing. We are going to try to add fluid interactions if possible. If by player does not equal null and player's inventory manager does not equal null, if hotbar slot dot is not equal null and hotbar slot dot and not hotbar, okay. So if we're not in debug mode and we're not carrying a stick, if tool is a wrench, then we have fluid interaction. Okay, so we want, you know what we don't have in here? We don't have, oh, there's the tri-axis. Okay, good. I do have permission set. Okay, now we want to see iLiquid source equals hotbar. Well, I think I short. Yeah. item slot hotbar equals player by player dot inventory manager dot active hotbar slot. Just to make it easier to, so I don't have to type all of this, right? I should have done that up here, but you know, it is what it is. I can always move it later. Let's just get it done. Where do I need to find my spot here? Source hotbar dot item stack dot collectible as I liquid source. If source is not equal null. Okay. Again, this is all like crazy amounts of just vanilla code. If not source dot allow held liquid transfer return. What is going on with the fucking IntelliSense today? False. Item stack to move equals source dot get content hotbar dot item stack. The get content here, this is a fluid, this isn't fluid interaction, right? So it's, instead of getting the block entity or item entity or the entity and just grabbing the inventory, it's, you've got to do all these hoops and it's just annoying. If or to move does not equal null and to move dot stack size is greater than 0. Okay. Where's that? Okay. This is where that bug comes in. I had to fix these. I had to fix this bug in multiple places, but people were saying that if they had a stack of buckets that was unloading all of them all at once. This is why. You used to not be able to stack buckets that had stuff in it, right? Even if a bucket was full, you couldn't stack it with another bucket that was full. The full buckets would not stack. But they made that change where they were able to stack. So I had to come in here and do a whole bunch of code to basically clone the stack, set the stack size to 1, and then use that stack to push the value. It was just crazy. To push equals new single bucket dot collectible as I liquid source dot get content single bucket. Oh my god. Single bucket. There we go. else to push. Jesus. You'd think it would like favor local values to push. Thank you. Equals new. No. To move. So, this is the to push, right? This is a dummy slot. It's either a single bucket, right? It's a stack size of 1, single bucket. Or if stack size equals 1, then we're already carrying a single bucket, then just set it to that. Okay, and now we have IVE liquid interface. IVEL equals la 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 la. We have this is VEB MB entity core MB core equals world.block accessor.get block entity of entity core okay. If source does not equal null and MB core is IVE liquid interface. Okay. So we grab the core at the position this is going to take some testing. I think it's fine. I think it's fine. Maybe. Well, we'll see. We'll see if it works. It may not work. So MB core as iLiquid interface. Okay. Now we need to actually swap. This is code universal to all of the multi-blocks again. Right? This is a base change. So if you have a bucket of fluid and you're trying to put like a single bucket of fluid into a machine, a multi-block machine, this is the code that actually transfers the fluid. So we got to be careful with this. Item slot liquid only push to equals item slot liquid only. So IVL dot get liquid auto push into slot. Why did this get liquid auto push into slot? Block select dot face to push if push to equals null, return false. Well, return true. Returning true, by the way, or true or false in this particular case, controls whether the server, whether the call is synced, called on both client and server. Okay, so now all of this validation. Now we need watertight containable props, water props equals block liquid container base dot get containable props of to move int cap free equals int push to dot capacity liters times props dot come on w props dot items per liter. If only that were standardized, God, it would be so much better. Push to dot stack size. Or no, that was push to dot stack size. Okay. Int num moved equals push to dot try take. Wait. Try take from item slot large liquid. Yeah, this is not okay. To push dot try put into sync slot push to World quantity to push dot stack size. Amount of moved items. Okay. If num moved greater than 0. All of this for a bucket interaction, by the way. Okay, so where is this call from? Bar slot. Oh my god. Um Damn it. I don't have... Is it... It's public. So this is why, like, the calls technically are in this block liquid container base. So in order to actually be able to access these, I would need to create an object of this. But these are multi-block. This is a multi-block base block type. It's not derived from that object. So in order to actually access these values or these functions, I have to do custom versions of these, which is why I have this split stack and perform action in here, because this is again a call in this function or in this object, right? We have split stack and perform action. This thing it's really nice, but the fact that it's tied right to an actual block base that I may or may not like derive from means I can't do this. So rather than put these calls in helper functions, which would be the best thing, because the call is the call. It doesn't matter what it is. So if I take do liquid moved effects, right, which is again one of these calls, well, this can be done with anything. So why not do this as a static in here? Okay. And then we want to pass in I core API API LAPI. Okay. And then we want to grab this. Go that. And that. Enum liquid direction. Pour. Okay. Interesting. Pour and fill. Interesting. Okay, now, so this is it's a static, which means you have to pass in whatever variables, right, that you want to, any instance variables, including the API. So if we need access to the API, we have to pass it in, because the static call doesn't matter. It doesn't care what we have access to. So all the other variables in here are variables that are legitimate. And this call here is also a static, right? So then with this helper function in there, we can come in here and just do VE helpers do liquid moved effects. We want to pass it the API again. We want to do by player. And then we do to move. Num moved. Enum dot pour. Done. And then we do delegate where's my call here? MB core dot mark dirty true. Return true. iLiquid sync. What is an iLiquid sync? I have a feeling that the bucket is going to be one of these as well. Barrel. Okay. I don't think I need the iLiquid sync block of code. Just because it's the interaction, the iLiquid sync interaction, and again, here's what I'm looking at here. Right. So we just did this block of code here. So this is what we just did. Is I
I took this and I made it apply to the core, the multi-block core. This, right? This here is the actual item itself, the hotbar slot. If we're holding the item, okay, if we are holding essentially the core, right? Imagine you're holding the core in your hand and right-clicking something. It's not it's not a valid action because it's the core, the incomplete, unbuilt core in your hand is not a tank. It's not a thing, right? We're not interacting with the core as a liquid sink, right? A bucket, when you right-click a fluid, a bucket can pull from that. But a bucket is... I don't think a bucket is a sink. I think a bucket is the source. We can check that. Bucket. Block bucket. Liquid container top opened. Liquid container base. So, bucket is both. Oh, man. So, yeah. A sink or a source. A sink. If the hotbar slot is a sink dot allow, hold on, let's see. Oh, it's X. Oh, I think we still might need it. Darn it. Okay. This should be pretty fast though. So this, I think the source, if I'm reading this right, the source is if I'm trying to put fluid in, and the sink is if I'm trying to take fluid out. Okay. So this return true ensures that this code is not run because if I didn't do a return here, it would it would put it in and pull it out in the same motion, because it would put it in and then the very next call would pull it back out again. So we don't want to do that. So that's why that return true is kind of important. So I liquid sink equals hotbar dot item stack dot collectible as I liquid sink if sink is not equal null, if not sink dot allow held liquid transfer, return false, item stack, come on, item stack. How many times have I written item stack? And it's still like, nope. Not sure why I name these such long names. Own content stack equals get content. Get content. Get content. This is what it's looking for. How did I do this? What would be a good example of a multi-block This is an example of how I solved it here. This is why I was looking at this. The pull, I'm pulling from up here. Okay. Because that is the machine, essentially. So if we come down here, MB core, item slot liquid only. IVEL is the block entity as IVE liquid interface. I need to float this one as well. Okay, so I already know the MB core is the interface. So coming in here, I want essentially this down here. So I can share that value across both of these calls if I need to. Okay. So if sync item slot liquid pull equals IVEL. Why don't I have I need to go there. Or no. Oops. There. Remove all of this and move it here. There we go. Because this, if two move in stack size, right? So it's only when the bucket is empty. No. That's actually wrong. I want to move this to here. How do I capture liquid source bucket design with null? Okay. This call right here ensures if the bucket is empty, it won't run this. It'll come down here and try to then push or pull instead of push. Okay. And I think I want to remove these back down to here. So if this bypasses this and we come in here and we say, all right, if sync is not null, pull is IVEL get liquid auto pull from slot block selection dot base and pull not equal null. I do have a catch in here. If pull equals null, Jesus. Just stop with the IntelliSense. What is my block entity called? MB core. What am I doing with this? Block entity container. Block entity container, blah, blah, blah. For each slot ID. Okay, yeah, this is not required. If pull does not equal null, again, we're pulling the multi-block core. Like, we're pulling that. I know that some machines are like liquid interfaces and some are not. If it's not, then just skip this. We don't need any other gubbins. I'm the one that controls whether or not that is valid. And so this is pull.itemStack. If own item stack equals null, return true. Or instead of doing this, we can say not equal to null. And then we say, all right, item stack liquid particles equals own content.clone float liters Oh my god. You need an entity. You can't just auto select entity? This is a different. Oh my god. Really? What are you? The braces are in. The IntelliSense can not detect that the braces are in. Pull.take out. Move to. MB core. Dot mark dirty. Return true. Okay. This should hopefully be it. Maybe. I don't know. Possibly. I can close that. Okay. This should help, or at least allow me to put a bucket of something into the generator. That's kind of what I'm going for here. So if we go back to the generator again, if we interact with it, it should be able to push into, because get liquid auto push into slot. Taking stuff out. Rotation side. Do we need the ability to remove fuel out of this thing? Is that something we need? Or, once it's in, it's in. Because the pull from slot, remember this, right? This call would return no. Pull would be no. So it wouldn't actually run this. Trying to pull the stuff out, it wouldn't work. You'd push it in, but you couldn't pull it out. Okay. So we want a breakpoint here. We want a breakpoint here. And then Okay, I think. Put out the power per second value of what it's going for. Or, what it's targeting. The instant power per second is not really reported because, again, that's the server is ticking it 10 times a second. The client is updating twice a second. So for every 5 server ticks, the client gets one update. So you're not going to see up to the millisecond values in terms of where you're at, because if I were to push, and you want to be very wary anytime you're playing a game, a client server game, and you get incredibly up to date, up to the millisecond information. That can be done one of two ways. Okay. One is the factorial style, where both the client and the server are simulating the same game, where the server is just updating the client and saying, hey, this is my current game, my current game status checksum, right? We need to sync that together. Right? So the clients are simulating the game. Every client is simulating the same game. The server is doing it as well, and the server the server is the master. The clients, while they're simulating it, if the client data is different than the server data, that's where you get the desyncs that are thrown. Right? Anytime the client data does not equal the server data, boom, you get a desync. Right? And the server is the thing that controls that. That's one way, is the factorial style. The second way is the server manages everything and spits updates to the client. Right? When you move a fraction of a block, that entity position gets thrown to all the other clients that are connected, and therefore your character moves. Right? So this is where you get rubber banding effects, where if you have lag or slow connections or packet loss, you get the jumping effect because that position update stream gets blocked or delayed or something, and you see skips. In this mode, this is how Vintage Story does it. In this mode, if you are sending up to the millisecond data constantly, you can imagine how much packet bloat that would cause. So you have to be careful when you're coding things like this to not absolutely spam the updates, right? So that's why I have this little update bouncer. So the update bouncer just ensures that the clients are not getting crazy number of updates constantly. So you're gonna see little delays, little things that may not look right, but that's just because the server is updating much, much faster. It's a lot easier for the server to simulate something fast than to update clients as fast. So when you're looking at a Minecraft mod, this is why factory style games can cripple your TPS on a Minecraft server or on a Minecraft game, because you have all of these different mods that are spitting data like up to the millisecond data to the clients. The server just gets completely overwhelmed. It's just not sustainable. So when you're looking at a machine like in Mechanism or something like that, and you get these smooth, like super fine-grained updates and progress bars, that's a huge amount of data being sent to the clients. It's really not good. So if you're on a client-server situation, you just have to put up with delays in updates, because then you're not only, if you have servers, you're not spamming the trunk line, right? The internet connection, because some servers, they gate the amount of traffic that you have, like AWS does this, where you have so much bandwidth that you can use, and if you are running a server that just completely saturates that bandwidth, you got 5 players, right? Imagine how many packets a server generates if you have a server that's updating machines 10 times a second, and you have 5 people logged into that server, and every one of those machines is updating the client 10 times a second, and you have 5 machines, right? That's 5 machines times 10, right, per second. So 5 times 10 times 5 is how many packets per second is being sent from that server just for those machines. That's a huge amount of data. So I scale that way down. And then again, when they're sleeping, it's even less. It's way less when they're sleeping. Then it's once every 2 seconds instead of twice a second, right? It's 10 times less when it's sleeping, which is why the sleeping mechanic is so important, because it's not spamming the client with updates. When something is asleep, it's not doing anything, right? It's just sitting there. So yeah, little optimizations like that are vitally important if you're doing a mod that's running stuff in real time. Okay, so here we go. We have is built, machine state is on, and is burning. Is client, let's see, electric power minus current power is less than or equal to rated power. Good. So the big question now is, if this is false, do we sleep? And I'm thinking right now is no. We don't go to sleep if power is maxed. Right? We don't want to go to sleep if power is maxed. We're sitting there because at any moment power could be pulled, right, from this. So what I think we're going to do now is we're going to build. I need to get into the game, place one of these down, get it built, or get the schematic, right? Get the multi-block schematic in the game and copied and pasted so we can actually build what the schematic looks like. So let's do a debug. This is going to take a couple seconds to load up. Since I'm in debug mode, there's a lot of stuff that it loads. 15,000 block types. I don't even have that many mods installed, and there's 15,000 block types. That's wow. Oh, Jesus. Aha. Yeah, okay. I forgot about. Damn it! I forgot about checking whether this was null. If liquid fuel prompts is not equal null. I forgot to check whether that was null. All right, I'm gonna go to the bathroom. I'll be right back. And there we go. Okay, so we can test this. Do I have a bucket? I do. Let's grab some diesel. Wow. I don't want 10 liters of diesel. How about we do naphtha? You don't seem to be calling. To move. Naphtha portion. To push. Naphtha portion. 60. $60. To move. Source.get content. Where attributes? $60. There were only 6. There was there was 0.6 liters. 0.6 liters. That sounds about right. So push 2 is null. This is why it's not working. Dot face. I need to do this. I need to go into this. Block facing is west. Get clockwise. East. Rest. Oh, I did a thing here. I need this to be an and. Hot reload. Can I do that? I can. Okay, that now should be valid. So it's saying capacity free. I have 80,000. Remember, that's 80 liters or 800 liters. So I have 80,000 capacity for portions. And then the try put into it's just we're bouncing around like crazy right now. Why was it doing what is items? Okay, there we go. Input slot dot item stack dot item attributes. We have 3. We have liquid fuel is part of there. Okay. So liquid fuel exists. Liquid fuel prompts is good. No, that's why is that null? There it is. Yep. Return true. Okay. Find matching recipe. I don't even know where I'm at this moment. Okay, well, we debugged the fuel. Now we need to debug the actual burn because, yeah, this thing does not have any power in it. Oh my, there's literally I need my night watcher. So let's give item night watcher. I don't know what I did the first time. That was weird. It doesn't close open rifts, but it will prevent rifts from spawning. Okay, so now the problem is we have on sim tick. So this tells me is sleeping false. Is burning false. Whoa, wait a second. Do I have any LV generators built in this world? I might. I didn't think I did, but... Mark dirty, true. We should be getting... input slot dot empty. How do we still have stuff in the machine? Okay, I need to get back. I need to get back to even here. Not going to be the schematic, by the way. That was just temporary. Do I have any? Oh, I do. I was like, okay. Okay, I need a little space here. Okay. We need to face north. Ooh, I have flax seeds on me for some reason. So yeah, we need to face north. When I do this, trying not to get too close to that, because it'll make my gear spin super duper fast. No, I don't need any of that. Okay, so we want give block VEMB fluid generator built north. I gave myself the built version, so when I place it, it's built, right? That's what it looks like. Then what I do, this is the process that I use to build the schematics. Then I want to build the schematic on how to do that, so I take the the incomplete version, right? This is what I just broke. I can take the incomplete version, and remember, everything is centered around the core. The core is the center. So we build that facing the same direction, right? Incomplete north, which is the same direction, and now we build the schematic on what it's going to take to build this thing. Okay. So I think we can do heavy engineering, and since this is a new world, heavy engineering, give block VEMB component heavy engineering, 20 of those. Light, 20 of those. We want just how expensive do we want this to be? I think I need some of those while I've got it there. I'm going to need multi-block I/O power. VE multi-block I/O dash power. I don't need 20 of those. 10 of those. Fluid. Item. Didn't really need those, but whatever. I did those already. BE sheet metal iron. 10. Just for funsies. Okay, now, what do we want to do with this? Well, now we want to build what the schematic is going to be for this little guy. We can do treated wood slabs. No, we are not. No treated wood slabs. Iron or steel? We go iron. Now, just a rough, make it just expensive enough to be like, ooh, it's gonna take some planning. All right. Once we got all that done, we need to dig down to the core. And then the shenanigans are going to have to start. So, game mode 1, 2. Oh, they still haven't sped up that. Oh, Lord. I need a wand. Selection mode, please. I want you to go there. There. And then I need to grow that direction one. No, come on now. I can never know which one of those to do. All right, so we select the volume that makes up the multi-block. Make sure it's all good. Right? And then we go down. We look at the core. This one here. And we do WEGMC. Boink. And that prints out in the log. Right? This is the log if you just have the text log, right? This is the stuff that it prints out. Multi-block structure. The GMC stands for Generate Multi-block Code, I believe. That's what it stands for. So we then highlight and copy that. We take this and we clear, disable, /WE, game mode 1. Set that back, get us all back to normal. Put that up in my inventory because I don't need it right now. Okay, save and leave. Now we go into the generator itself. And I've already copied the multi-block structure, so we just need to paste the new one in. Okay. Before I do all the gubbins here, I want to see. Yeah, so you can see this steel is actually 2. Okay. So let me do a new text file, and I'm going to do the block numbers here. Old, new, okay. And then basically all of this can be deleted. Okay. And we want to do Okay. Okay, so now the reason why I wanted to save like what my old numbers were to my new numbers was for the color, for one, the highlight colors, the mappings, what mappings have to be done, attachable. This is when you place the power connector on the top. That's how I manage that, and then the attributes determine the orientation of how things are faced. So there's a lot of little customization here. This is kind of the ickiest part. Let's move into new window. Okay, and I just want to make sure we run through this really quick. So the old numbers, right? The old colors here. We want to set these up to be the same colors if they're the same block. This is kind of the tricky part. I really wish I could do the mini dimension thing. That would make this so much easier. But you can see our block number heavy engineering is 1, while our new heavy engineering is also 1. So we don't need to change heavy engineering. 1 is set. 2 is power. But 2 for us is our steel. So 2 becomes 5, basically. So we're going to move this to the side here. So again, 2 becomes 5. And then 5 on the old is slab down. 5 we don't even need. So the old 5 we don't even need because we don't have treated wood anywhere in this design. Right? So our 5, the old 5 was the treated wood, which we don't have. So this can just live up here. And then this 5 we can put back. So yeah. So 3 is the light engineering block, which was 6 on the old one. So we take 6, we set that to 3, and then this, the old 3 was the interaction block, which is now 6. Awesome, these just swapped. So the block types between 3 and 6 just swapped. Nice. Okay. It's funny. The block 4 is always, for somehow, ID4 is always the core. I like every single one. Block 4 is the core. Which I don't need a highlight color, but I'm going to include it anyway, just to prevent it from crashing. Okay, so we need block 2, which is the power. So power is 8 on the old one. So this 8 is actually 2. Okay. And the reason I do it like this is my blocks are all, like the block types that make the components, right? The components that make it up. I'm sharing colors. Like I want the interaction block to be the same shaded color across all of the schematics. So it's just like just for consistency. Okay, so again, block 4 is not really important. Block 5 is the steel, which we already copied and pasted over. Block 6 is the interaction, which we've already done that. Block 7 is sheet metal. So sheet metal, iron, and then multi-block fluid is old 7. So 7, this is the old 7. This needs to be 8. So now, and 8 is it. 8 is the last block. So 7 becomes 8. Power is 2. Three, 4, we don't map. Do we not map? No, we don't map 4 because 4 is the machine. 5, 6, and then 7. 7 is the sheet metal. I need to grab whatever color that is. But we do know that it's a none as far as what block to change it to. And then the power is block 2. That's the attachable. Orientation, the only one in here that has an orientation is the core, and we don't care about that. And then again, block 2 is our power. It's just specific attributes to that. Okay, so the sheet metal, I believe we could grab whatever color that is from the distillation base. So the sheet metal here is 1. So sheet metal here is 7. 30, 30, 30. So it's a dark color. Not quite black, but it's a dark gray. It's already a none. 8 is fluid. Let's validate that. Power is 2. Interaction is 6. Ooh, that would have been bad. 6. This would be 4 or 3. 3 here is light engineering. Yeah, that's a none. 4 is not. We're not swapping 4. 4, the actual core itself, it's automatic. It automatically swaps it to the built version, not the incomplete version. 5 is steel, so that's none. 6 is our interaction. 7 is just sheet metal, and 8 is our fluid. Excellent. That is our schematic. We need then, I can close this. We want to grab VEMB fluid generator incomplete. fluid generator core. Nope. I just want one. Okay. And then we want block description. I don't know if there's an option in VS Code to not select the whole. I just want to select the word, not the whole string. I wonder if there's an option for that. Okay, we can worry about the description here in a second, but block description. Okay, the description burns liquid fuels that contain that are item liquid fuel type and contains a liquid fuel attribute. The portion burns liquid fuels that are the item liquid fuel type and contain a liquid fuel attribute in the fluid portion JSON. Use DIESEL portion. Use diesel portion as a template if you wish to add new fuels. Multi-block. Multi-block building. Multi-block building blocks are color coded by type as outlined below. What I usually do because this is a royal pain in the ass to do. Okay. You know what would have been smart is to copy the pump jacks version of this. Somewhere in here. There it is. Because the pump jack was the original one I copied it from. And all we need to do is add okay. Now, dark purple, heavy engineering, component steel, interaction, slab down. Yeah, this one we don't need. Brown. Pink is light engineering. Yellow is fluid. Lime green is power. And then we just come up here and go distillation tower. Whichever one. Where is power? Multi-block fluid, light engineering. Concrete. Heavy engineering. Ladder. Metal platform. Sheet metal. Oh, it was the first one. I thought it was the last. Black. Come down here. And go here. 2, 3, 4, 5, 6, 7. That's only 7 blocks. Oh, that's right. 8 blocks. The 8th is the core, which you couldn't even get this information if you didn't have the core built. So, okay. Dark purple, light gray, black, red, black, pink, yellow, blah, blah, blah. Okay, so those are mapped. So now we can put these all on one line. So if I were to if I were put in charge of completely rebuilding the handbook, let's look at this from a realistic position. If I wanted to rebuild the handbook to be as edit friendly as possible, these descriptions, what I would do is I would be able to create a link, right? Instead of an actual string, point it to a custom file, almost like an HTML file. And that file could be its own thing. So if you need, you can make it a string, but then you could add a custom code of like we have the item stack code, right? Like this item stack. Rather than do that, what I would do is add a file, right? File or external file or whatever you want to call it, that just points to a file that's in the lang, right? You would just have a directory or something of whatever, right? en underscore whatever. It doesn't matter. But you would have a file in there, and then each file would be its own document. And the handbook system would just import that whole file and build it how it looks. That's how I would do that, because it's really annoying needing all of this shit on one line, which, by the way, applies to the guides. So the guides are these long strings. Look at how long that is. Like, that is 2,700 characters. Right? That entire guide is on one line. It is really, really annoying. Trying to edit those. Like, crazy. So yeah, would be my number one thing that I want to do. Like, it's so crazy. Okay. So, fluid generator incomplete, fluid generator built, blah, blah, blah. Okay. Now, with this done, we should be able to run it again. Now I want to debug the actual burning and like make sure that the loop is good. Because for some reason it was wonky. I don't know why. But now when we break, so those the two that we built, right? The two that we built, where we just placed down the built version. So this one right here. When I break that, it's going to turn into this. Now that we have that defined, it's going to turn into this. Right? I may want to use a less crazy pickaxe for this. Okay? And then to re-verify, to rebuild it, all we need to do is click that, and good to go. Okay? So now we could actually do that, and that's good to go. So that's where, like, I validate, hey, this thing actually works, and now this thing has collision boxes, right? Now this thing actually has substance, which now allows me to build stuff on top of it, right? I can place that connector. So if do I have any more of those connectors? I do. So I should be able to place that right there, just like that. So that shows me that that's working. Because if that wasn't working, I would not be able to place the block on top of that. It would not allow me to. Okay. Now, the radiator is good. Everything is good. I could have probably avoided that, but whatever. It is what it is. So now I want to debug why when I put fluid in there, let's again grab maybe a tiny little bit. And I want to go in here. Where do we want the breakpoint? I've already got a breakpoint here. Is burning. Okay, so I've already got a breakpoint right there. Good to go. So if I put this into here, LPG, it's saying there's stuff in there. Is burning is false. Okay. So if I do one there, take that one away. Now, doing this again is not going to pull the fluid out. Hmm. If is built and is burning. Come on now. I keep hitting the wrong key. If is built and not is burning and input slot dot empty. God, I did it again. I cannot, my wrist does not bend that far. If is built and not is burning and not input slot dot empty. Is burning equals find matching recipe. Hot reload. Okay. Then we go F11. False. Get type. Okay. That was good. True. Liquid fuel prompts should be good. Return true. Is burning true. Now we come in here. We go rated power 136. Electric power. Excuse me? Oh my God. It's not, it wasn't going in there because I'm debugging, and the amount of time that passed, it doesn't take into account the fact that the game is paused while I'm doing this. So the delta time increases dramatically, right? So burn time is now 2.7 seconds. Current burn time is, come on now, greater than or equal, why? Oh, 5 seconds. Okay. Yeah. Electric power. Update the client. Yeah. The stupid rated power again. Okay. Current burn time now is 8. Burn time input slot dot take out. So now we have input slot. We have 30. So we remove 1. So now we should have 29. Yeah, 29 is burning as true. Okay, so now if I remove all of these, you can see the power climbing, and boom. Now it's not gonna top it off, right? Because it's the burn tick exceeds the available space. If I change that, right? If I change that to top it off, it would void the rest of the power, right? The 8, it's literally 8 power. Well, it's going to try to, it wants to make like 130 power, but there's only 8 in there. So it would void, 120 something power. Okay, so what we want to try then is this. Let's break this. Right? So now we have this thing which wants a lot of power, and we have that which gives us a lot of power. So fence. Give block wood fence. What? Give block wooden. Sorry. La 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 la. That's LV. Let's give block wire relay. MV power up 20. Okay. I need maybe a debug Duvalaki here. Get block info. Input tank. It's a percent. Input. Input slot. Dot item stack. Dot stack size. Portions. If input slot dot empty. Oh my god. I need to know exactly how many portions are in there. There we go. Why, what is going on now? Distillation core. Get block info. Where is it at? Okay. Oh my god. Recipe progress. Let me peek. Peak definition. Okay. I know this works. Like I know it crafts. I just don't know why it's not rated power. It is what it is. Current power. Current rated power. Okay. Current power. Rated power. Current power. Rated power. Current recipe. Num extensions. Has room and output. Recipe progress. Recipe power applied. We have 139,000. Now 142,000. Okay, recipe progress. We should at least be a quarter of the way there. Am I not syncing? Yeah, I'm not syncing the recipe progress to the client. That's why it's not reporting it. Max temp, gen temp. Yeah, we have some data, but we're not sending actual like recipe progress data. Okay. Why is recipe progress still 0? I need to go to the definition of this. Why is this still 0? Empty, false, current recipe. So 154, let's just do the calculation. 154, 790 divided by 1.5 million is 10%. Right? Power per craft. Recipe power apply. Oh, it's a long. Okay. Float. There it is. What am I? Recipe progress is now 0.1. I completely forgot we have max extensions onto this, right? Which means it's a 1.5 million power craft rather than less. So yeah, we're gonna need a little bit more juice here. This is probably coming out. We got 5 portions left. Let's throw one on here. All right, this one is showing empty, but it's showing the wrong power per second. Okay, let me grab the rest of this, put it in here. Okay, so now we gotta see if we can fix that craft. Because remember, the server is grinding away, right? The server is going. We're not sending those variables to the client. Okay? So that's why we're not seeing any recipe progress. So we are gonna need craft recipe applied. Recipe progress. Oh, we are. Recipe power applied. So if we have recipe power applied, then why aren't we seeing on it's so hard to find get block info recipe progress. Okay, boink. Okay, so recipe progress we're still showing as 0. So if we go recipe power applied, we have recipe power applied. Current recipe is null. That's why. Do we have the inventory? We should easily have the inventory. So what I'm missing, I think, is a call to find matching recipe. And then if we go to definition, APIs null, return null, input slot.empty, blah, 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 M recipe, good. I don't like this. I don't like that this resets this. This should not be resetting the power. Unless we go here and then override it. Okay. What? This should 100% be working now. Tree. Is it number 11? Okay. Recipe progress. Current recipe is still null. What? Input slot, crude oil, num extensions, for each in M recipes. So this would be cider, cider. There's like 35 recipes in here. Crude oil. Spirit. It's not finding the recipe. Let me do a breakpoint with a condition on M recipe dot num extensions 6. What? Num extensions 6. Where is num extensions set? Num fluid outputs -1. Okay. Clone Num extensions. Whoa. Okay. So we have a flaw. Yeah, the server is not happy. The server is not happy with me right now. Literally no recipe was set where num extensions was greater than 0. So where I set this was here. Num fluid outputs. Matter state liquid. Okay. Item slot liquid only. God fucking damn it. Item stack. Collectible. What? Jesus. How is item stack set, but collectible isn't? Like, I don't know. Like, that's crazy to me. It's ticking so early that it's trying to call that before the API is set. So I probably need to do the fix. Yeah, I need to do the fix down in the from tree attributes. So num extensions 1. Hey, look at that. 2, 3, 4, 5. Matches 6. Boom. Current recipe. Set state. Return true. Remove that. What is going on with this lag? What is that? Come on, game. There you go. Now you're loaded. Fluid generator. I still have no. Really, I still have no faces. I'm gonna have to check the generator again. That lag spike is really bothering me. What? Settings. Dev. How do I get... Is there no way to profile? Okay, so that, for some reason, that recipe progress is still not returning what it needs to return. Power applied. Current recipe is still null? Excuse me? How is that possible? Input slot, crude oil, number extensions, 6. Run to cursor. It's not seeing it again. It's like I fixed it and then broke it again. What am I missing? What simple shit am I missing for this? It's not finding. It's just too much to scroll through. How? M recipes. We have 35 recipes. Num extensions. Okay. So we need to look at... Can I just freaking add it down here, please? Num extensions 0. Didn't I just fix this? I could swear that I just fixed this. How? How is this so wrong? There is oil in the lookup. I mean, there is oil in the input slot. How is this? I'm going to put a breakpoint here. Conditions. Yeah. You can see there's crude oil in there. All this goddamn work. For some reason, it's like the server is finding the recipe, right? The server is finding the recipe. So the matches is passing on the server. Which is bizarre, right? It's like it's finding it on the server. The client, the recipe loading, I don't think is. Yeah, the recipe loading is both client and server, so it's not like weird. It's lopsided. I don't need this open anymore. This is such a weird. All I'm trying to do is locate the recipe on the client and the server. Like, why is this not running right? Num extensions, right? 1. L extensions 1. Ingredients, crude oil. Why am I getting past 1 extension? Excuse me? All stack. Find matching recipe. Line 100. Initialize. Why do I only have one extension? There's the 6. Six and 6. Requires we are on the server. Yeah, there's a hitch somewhere. There, it like goes away and then it comes back. Okay. So why in the find matching recipe I'm on the client. Num extension 6. No, num extensions 0. None of the client-side recipes have this num extensions set. None of them. Right? This output, I know this has got 4 outputs. We should have at least 1 extension on here. We actually have 2 extensions. Yeah. We have diesel, which is the base, and then heavy oil, and then lubricant. So it's like this should have num extensions greater than 0. But it doesn't. Why? Okay, let's go in here. I'm going to do a cheeky little Duvalaki here. Requires, okay, so return false. If num extensions equals 0 and outputs dot length is greater than 2, resolve. Num extensions equals outputs dot length minus 2. So outputs dot length in this case, num extension is 0, but our outputs, right, is diesel. Come on now. Bitumen, diesel, and heavy oil. So num extensions should be, and we're on the client. I don't know why. I'm still not seeing. God, how is this still not right? How am I still not seeing it? Current recipe is set. There's recipe progress. Why am I not seeing the bar? I shouldn't have to put the 10 in there because it defaults to that amount. How is this? Percent to bar. Recipe progress times 100. is set to 0. What? Excuse me? Oh, now it's all squiggly? Recipe progress. Recipe progress. Okay. I'm just gonna stop it. What is my error? I don't have an error. Okay, let's try that. Yeah, I was getting some weird casting issues. I need to multiply recipe progress by 100 and then cast it to an int. I was casting recipe progress to an int and then multiplying it by 100, which it was casting it to 0 and just sending it to just multiplying 0 by 100, which was 0. So a little order of operations shenanigans there. This should work. There it is. Oh, thank God. And our lag went away too. Magically. Amazing what happens when you fix a bug. Okay, so the reason why this is so damn slow, right, is because it's way more power hungry. Although this has power in it. Why do I have an error in my MV network? Let me break these and these. We should all have no network on them now. Yeah. Okay. Eat some blue cheese. So the fact that this still has power in it means my network is not pulling power from the MB network. Okay. This is going to be a very dirty amount of code. Okay, update tick. Are we paused? We are paused. Okay. Let's see. I'm seeing if there's any artificial cap to how much power we're moving. I'm not seeing a cap anywhere. So I think we're going to have to just follow the tick from one of these and figure out what it is. Okay, delta time is a 2.77 or 0.277. That's fine. All nodes. Network power per second. Where is this? Network power per second. Where is this value? Is this value used anywhere in here? Find all references. No. The value is not used anywhere. Where is this set? Find all references. This has got a few uses. Weird. Okay. Producer nodes is 2. Power in Gen 209. This should be a lot higher. 763. Storage nodes we have 0 of. Total power offered is total power in generator 763. Consumer nodes we have 1. Total power offered. So entity does is loaded. So total power offered is receive power. So this would be, it should turn this to 0. Oh, you know what I didn't do? This is why. Okay. No, it should still. Yeah. Okay. Delta time is going to be crazy. Delta time. Can we get it down, please? Receive power. Go into that. Max power per second. This is the problem. Our power per second is wrong. Oh, the wolves are out and about. Um, so, how do we alter the power per second rating of a machine dynamically? We need a function that alters the power per second rating of a machine, unfortunately. Let's just do set max power per second. Sets a new rating for this. And power per second is a U long. Yep. Then we have to go to where I implemented that. We're going to have a red squiggly here, right? Because it's like, hey, you changed the interface. How could you? So we want to take and do virtual, I think, rated cheat. Let's just do public virtual void set max per second. Okay. Okay. So here's the problem. The power per second rating is always called Damn. If property does not equal null and max power per second equals 0. Initialize. What I need is max power per second. Oh my god. If we can extract power or we can receive power, we want to set the max power per second. If we can't do either of these things, there's no point in power per second doesn't matter because we can't do anything with it. So set it to 0. And then come up here and just return it. Okay. Now, wow, my little preview box for my stream is like 20 minutes, 40 minutes. It's 40 minutes behind. I don't need it. I don't need to watch where it's at. Okay. So the whole reason for this, right? The whole reason for this is to be able to set it. Right? All we're doing is setting it. Now this change is going to break everything. any mod that implements this interface on its own is going to break. So probably lens bridge mod. I'm going to have to reach out to him and be like, hey, there's a change to the interface. You're going to have to just throw this function in, right? You don't have to do anything with it. You just throw this function in. Because if you implement this interface somewhere else, he doesn't have to. Like if he implemented the behavior into the block, that doesn't matter. Depends on how he implemented it. If he declared a block that derived from the interfaces from the other mod and the interface from my mod, then he would have to. But if he just added the behavior to his block, then it's fine. He wouldn't have to do it. But it's why it's in a behavior, because you just add the behavior to the entity and you get all of this stuff. You don't have to do anything with it. You just get the behavior. And this set max power per second, like, again, this is like a very internal thing. I set it to public because I hate when I run into private or protected or internal values. It's just like everything's public. But yeah, we can set max power per second. It's virtual. Public virtual Ulong max power. Did I not name that the same? Oh. Oh no. There it is. Set new power. Okay. I was like, why did this not get the value? But it's, yeah, there it is. And then this. Ulong max power per second. Get. Why am I not seeing? What in the world? How did that happen? When did that happen? I wonder. Okay, close that. There it is. That was weird. Must have misclicked or something. Okay. All right, we have max power per second. Now we are able to affect the power per second rating. I hope to God that I didn't completely foobar all the things. So we go to distillation base and we do find validate extensions, which is right above here. Okay, so now we come down and we say num extensions. Now I know I've got some variables in here. For the power per second. Yeah. Extension power per second is so we take the base power per second if num extension is greater than 0, we want to Ulong added power equals num times extension power per second dot Ulong. Why is this still icky? Okay. So the problem here is the power per second rating right? So then we need to go back to the behavior. Minimize that. Minimize that. Copy. Plus. Oh. Because one of the problems is if we set this, just hard set it. The next time it tries to find find a recipe, or the next time it validates the extensions, it's just going to go, oh, I need to add more max power per second, and it's just going to go. The power per second rating is going to be, millions and millions and billions by the time a couple seconds go by, which would not be ideal. So with the Boolean here, add to base, is all this does is say, take the value that I pass and just add it to the base, right? It's a finite, just keep setting that. And that way it's not accumulative. We're not adding. We're taking the base and then setting the new value. So that way, if you add an extension and I recalculate how much more power to give, say it's 500 and then it goes to 1,000, then I just add it to the base. Or if you set this to false, then it just sets the power per second rating. So it gives you the option of doing either. So then we go, if add to base, ulong properties dot as double max power per second to max power per second. Okay, and then we go back to here and we say true. Okay, so because I really can't, like, the electric is the behavior, but the electric is like, I could do like maybe electric.properties. Yeah, I could have done electric.properties and done all of that myself. But just passing true, right, add to base is just like add it to the base value. So I'm just, how much added power do I need, which is number of extensions times the power per second per extension. So if we have 2 extensions, it's 2 times 500, which is the added power, and then we just add it to the base power per second. And then the network, when it ticks, should see that, right? It should see that added amount. And completely empty that other generator. It might be empty by the time we get it rendered because it's ticking behind the scenes. Yep. Do I have a bed? I do have a bed. I would need 3 more. Could I fit 3 of those in there? I have so much grass on me. That would be west. One, 2, 3. And then, in order to have these proper, this is just a way to, if you're debugging, just give yourself the built version. You got to make sure to give yourself the version of the direction you want, right? This is the west, so you want to give yourself the right one, but and then I can do those and that. Holy crap, it finished. Okay, so let's grab another one of these. What? You should have no What is going on here? Something. Okay, let's debug it again. This is kind of what happens when you have many systems that are all essentially like, you know, working together, or at least trying to work together. Where's my update tick? There it is. Delta time is good. Producer nodes 5 is good. It's a good amount, right? So rated power, let's go back. Let's dive into this really quick. Max power per second. Rate is 500. Current power is less than rate. Return current power. Okay, so then we run to cursor. What is our power in gen? 2000. Remember, it's not the total amount of power in the generator, it's how much power we're able to give this tick. So, total power in gen is 2000. Consumer nodes, we have 1. So then we go receive power. Current power is not greater than. So max power per second, we have now 5,000. So power per second is now 1,300. Okay. And I add 2 just to, get us into the ballpark. Capacity, power per second is greater than capacity. No. So power per second, power offered, greater than power offered. So electric power, which is 215, plus equals 1,300. Power offered, so then we're going to return. So we did not use 700 power. Okay. Total power in gen, total power used, total excess power. We don't have any storage units. Total storage available. Total power consumed. Right? So we're extracting power now. So this. And then this. This. And then this. Storage nodes, we don't have any storage nodes. Total power consumed, total power available. And it's done. Aha. You see the power in here? Well, why did it drop? Let's go back to the where's my distillation tower? Get log info. So the power per second, I have 5 generators. I'm not understanding what is going on here. Are any of these out? You have portions. You have portions. You have portions. You have portions. And you have portions. It's a weird issue. This is where I wish I had like really robust debugging tools. Because the power per second rating of the generator itself is 2,000. So I'm able, there's no fluid that we have that's over that amount of power per second production. So that's fine. The network should easily be able to pull all the power out of these. I mean, it is pulling the power. I mean, it's running. The fact that it's like dropping every tick, it's going up and down. It means the network is pulling power out of it. But it should be able to keep up with it. It's really surprising that it's not keeping up with it. It's also weird that the percentages are only in whole numbers. If I pause that and I say float, well, no, not float. Do a float here. Well, I don't need, recipe progress is already a float. There we go. The N1, by the way, the colon N1 is just give me 1 decimal point. Number 1, N1 is 1 decimal. Naphtha and LPG. Diesel, kerosene, gasoline. Diesel and diesel. So when this gets done, we should have more diesel. 0.6, so we'll be up to 0.9 liters. We should get some, yeah, we should get some gasoline and kerosene. I mean, it is processing. It does admittedly take a long time. It's supposed to be a long craft. Boom. Okay. So you notice how it was sleeping? That's, again, when it goes to sleeping, it doesn't tick very much. So there's your 10.5, 0.9, 1.7, 1.9, 1.2, 0.6. So it worked. 100% worked. These should all be full or near full. And good to go. We now have generators, everybody. Many, many generators. Now remember, if you just had this one with no extensions, right, it would just take 2 of these. Each extension adds another 500 power per second. And again, there's a little bit of a rounding issue, right? There's a little bit of a rounding issue. But and the whole like Z fighting here, I really wish I might be able to fix that. If I go to blocks, fluid tank, gen mesh, cat. I know what time it is. I know what time it is. He's like, it's treat time, god damn it. You have one job to do. One job. And that is give me treats. I should have never started that. Okay, so fill height. So, yeah. Okay, so mesh data. Okay. I'm not going to call it because it hasn't updated. Fill height equals 1. Question mark. I'm wait a second. Okay. It's probably been 2.5 years since I've done this code. So stack size divided by items per liter. Which gives us liters. Right? So this is liters. Then divided by capacity, which is itself probably the number of liters. Right? So this is essentially doing 0.9 divided by 256 for the steel tank. This is why the steel tank is crazy. So 0.9 divided by 256 is a minusculely small number, 0.0035. So fill height is 0.0035. So we're subtracting fill height equals 1. We are subtracting, so this is false. Why fill height equals 0? Okay. So I need like fill height is going to be a tiny number. But it's a scale. Right? Like 1 means enormous crazy amount. So if fill height is less than 0.001, well, 5, fill height plus equals 0.01. Okay. But now to get this to redone. Fill height is a tiny, tiny number. Okay. So a minimum amount. And it will stay there until we go over that minimum amount that I specified, 0.005. Right? So as soon as the fill height exceeds that, it's not going to add anymore. But if it's under literally 0.005, under a 0.5%, then it's just set it to 1%. And that is 1% of that value. So that gets rid of that little bug. That's nice. So let's test. Let's test this. As this drains. And then, oh. And for some reason, power, it just evaporates, and it shouldn't. So maybe I have a little bit more. I maybe have a little bit more to do here. I might bump up. Okay. So let's do something. Let's do something a little wacky. Everybody ready for wacky? When we are putting power into a consumer, so producer nodes, we're pulling the power per second rating. Consumers, right? The difference here, there's two reasons why I can't just YOLO it. The power per second rating, right, of a consumer is also the amount of power that it's applying to the recipe. So I can't just go crazy on the amount of power. But what I can do is say, hey, we are a consumer. I can go into the receive power and say, give me a buffer. We have the power per second rating of the machine as far as like how much power we can apply to recipes. That's a power per second. But when it comes to like moving power around, I want a bigger amount of that. So we're going to go to receive power. And I need to actually do this in the behavior, not the interface. So electrical behavior, receive power. Okay. Current power, max power, blah, blah, blah. Math.round. Okay. So we're taking max power per second times delta time. Okay. So what I could do here is take this and modify it, right? Multiply it by some value. So we could take this and multiply it times 0.1. Okay. Basically taking whatever the power per second rating and adding 10%. right? Without actually changing the power per second rating, I'm changing how much it can receive for this tick for 10%. Now, 10% might be too much. Like 5% was probably even better. Because we're scaling it by delta time. But this should allow me to then basically consume more power. You can see power is not changing. Oh, now it just changed. What happened? Why is this now? Why did I what? How did I break it? Oh. Okay. Forget I did that. Forget I made that mistake, everybody. There we go. How? Pray tell. Are these not completely drained? I mean, the progress is being made. The numbers are kind of jumping around because of how the server and the client are updated. Again, I can't update. I could, for like debugging purposes, reduce the bouncer, right, as I'm debugging, but I would forget. I would forget to reset the bouncer, and I would saturate people's connection budgets. This should easily be pulling all of the power out of these generators. I mean, it is draining it. But I wonder if there is a power use issue, if we're using more power than we really should be. I just get the sense that it's like go to the distillation base. Oh my god. Oh my god. I think that's... No? Okay. I guess that's not it. So, given the delta time, 109.109. Oh, yep. That's it. That's it. That's what did it. Okay, well, that delta time is a little off. Same as that one. There we go. Yeah, this craft is supposed to take a long time, by the way. So this is supposed to take about 5 minutes. Now, I haven't timed it, but I really wish I could get rid of that stored food perish speed. Somewhere in here is that call, and I just want to get rid of it. So, anybody watching, what was happening is I was setting the max power per second, right, with the number of extensions, but then I was taking the max power per second and then adding the extensions again. I was re-adding it, so then I was taking 5,000 plus 3,000 and doing the power per second on that, and that's why it was not working. But I think I'm gonna still leave the 5% power for a machine in there. It doesn't hurt anything. It just ensures that the machine is, at or near full power if you're able to actually supply it. If it's a wash, then it doesn't affect it. The lap goblin is awaiting the moment. Yep. Okay. I'm just watching this. 93. So we should have 3.4 liters of diesel after it gets done. Pop. 3. Oh, yeah, there it is. 3.4. Okay, they're all empty. Glorious. All right. It actually works. Well, how about that? Beautiful. We have MV power, everybody. All I'm missing is like nitty gritty machine sounds and all that kind of stuff and things. Let's make sure the pipes can connect. Yep, pipes see it. And the other side. Yep. It's working. And if I really wanted to, oh, yep, it's getting power. It's just sleeping, right? It's not crafting, it's sleeping, but it's powered. So this thing is 500 power per second, right? So I'm pulling MV power, and I'm able to power LV machines with the transformer. Right? This would make a good screenshot. What is the... There's a hotkey to hide the UI. There it is. Oh, I can never remember the hotkeys. What is the... Is it F12? There it is. Let's get a nice... Oh, my... My axis was locked. Nice. All right. Progress. And we should have a bunch of bitumen by now. Not 100% sure why we have 0 stacks, but it's a weird. That was a weird thing to happen. And we fixed the tank bug, which is awesome too. All right. Well, that's pretty good for one day's work. So that's going to have to do it for today, everybody. I hope everybody learned something. If you didn't, if you enjoyed yourself, or if you just feel like it, please hit that like button if if you want. Subscribe if you're new to the channel, and consider being a patron or channel member and supporting the work that I do, and all of the work that it takes to not only maintain this mod, but all the other mods that I do. So any support would be very, very much appreciated. So thank you for that. But anyway, hope everybody have a great rest of the weekend, And yeah, I hope to see everybody back here on Saturday where who knows what we're going to do. So yeah, hope to see everybody then.